that SpaceX's new interplanetary launch vehicle is so big that it actually needs an offshore launch pad. It could be, because NASA briefly considered this for the Nova rocket in the 1960s, and that's what we're talking about today on Pigeon Space. Back in the early 1960s, when NASA was already looking at ways to go to the moon but hadn't settled on the lunar orbit rendezvous architecture that we are familiar with from Apollo, it was looking at a mission mode called direct descent. This is exactly what it sounds like, launched directly from the Earth to a landing on the moon, and then exact same thing coming home, launch off the moon's surface, fly right back to the Earth to land. This kind of mission would require a massive vehicle, something way bigger than the Saturn V, and that early concept rocket was called Nova. Some stats for comparison: the Saturn V had 5 F1 engines in its first stage to generate 7.5 million pounds of thrust. Nova had 8 F1 engines in its first stage and was designed to generate 12 million pounds of thrust. Not only is a rocket that big and that powerful technologically challenging to build and deal with, it is very loud, and that creates a whole other set of potential problems. Now, we all know it, but it bears repeating that sound is a physical wave. Sound travels by vibrating the molecules of the medium through which it travels. In the case of hearing a voice or hearing a rocket launch, that medium is air. Sound power, in the case of a rocket launch, is the mechanical energy of the exhaust plume. That's calculated by multiplying the thrust by the exit velocity, and it's a physical way to understand the power of the noise that you hear. Sound power is measured in decibels, which is simply a logarithm unit to express two characteristics: the amplitude of the wave and also the power of the wave. The higher the decibel, the more power, and also the bigger the amplitude of the sound wave. So, the higher the decibel, the more destructive its power. Now, this sound power vibrates through multiple frequencies, but engineers at NASA in the 1960s realized that the frequencies of a rocket launch tend to be in the low to mid-range frequencies. Those are the kinds of frequencies that can knock over buildings and break things. This is why a big, heavy rocket launching becomes a little bit problematic. This is really the problem of launching a big, heavy rocket. The bigger and louder it is, the more destructive it is acoustically. Preliminary testing of the Saturn 1C rocket in the late 1950s said that acoustic levels could be as high as 205 decibels, felt 984 feet from the launch pad. 140 decibels, which is the pain threshold, could be felt 9,842 feet away. So to get away from the damaging acoustics of launching a big, heavy rocket, some engineers in the late 1950s started looking at using offshore launch platforms. Some early proposals looked at launch platforms built 105 miles southeast of Cape Canaveral. This rocket launching would have the same physical advantages of a rocket launching from Canaveral, which is taking advantage of the Earth's rotation for easier access to orbit, but it would be so far away from the coast that the acoustic issues of the launch would not have as much impact. Now, it might sound insane to build a launch platform 100 miles off the coast in the ocean, but it really wasn't all that crazy. There were offshore oil rigs and also Texas towers that were home to U.S. Air Force early warning systems. It was feasible to develop some kind of system that would allow a rocket the size of Nova to launch from an offshore platform. Studies into offshore launch sites eventually determined that it wasn't totally necessary. The Saturn C1 was already under development, and recommendations said that it could be launched from land if all of Merritt Island was purchased as a buffer zone. This meant that populations and any buildings would be far enough away from the launch pad that the acoustic energy would dissipate enough by the time it hit those buildings to not knock them over. Of course, there are buildings close to launch pads, the Vehicle Assembly Building most notably, and all the buildings surrounding it are only about 3 miles from the Launch Complex 39 that launched Apollo missions to the moon. The engineers who designed the VAB knew that the acoustics of the Saturn V launching were going to pose a bit of a problem, and so they specifically designed the building to withstand that kind of acoustic assault. The building structure includes insulated aluminum panels fastened to steel girders to protect the structure and anything inside it from the acoustic disturbances associated with the launch. So Nova might have needed an offshore launch pad. The Saturn V didn't, but still forced some building considerations in the surrounding area. SpaceX's new interplanetary transportation system is going to be bigger than the Saturn V, therefore should have a bigger acoustic impact on the surrounding area. Now, as it stands, SpaceX is slated to launch its mammoth rocket from Launch Complex 39, the smallest rocket launch of Apollo missions to the moon with the Saturn V. So, will the SpaceX rocket be too big and too loud? moment, I guess not, but that could change as the rocket goes from concept to physical thing that's actually going to be leaving the Earth. So this is part 2 of my little 3-part series of Vintage Space considers SpaceX's new massive launch vehicle. So I really want to hear from the engineers out there on this one. Please let me know your thoughts on what the acoustic profile of a rocket like SpaceX's interplanetary transportation system might be. I also want to hear your guys' thoughts and opinions, and maybe questions if you've got them, on the history and potential future of offshore launch pads, because it is something that we kind of forget was ever really a consideration with early NASA. Of course, I've got more information on the acoustics of launch and the pros and cons of offshore launch pads in my latest blog post over on Popular Science, so definitely check that out if you'd like to know more. And of course, all the comments, questions, and thoughts in the comment section below. Be sure to follow me on Twitter and on Instagram for daily Vintage Space content. And with new videos going up every single week, subscribe right here